database modeling using entity relationship model. And this topic is data modeling using entity relationship model, commonly known as ER model. Conceptual modeling is the first and the most critical step in database design. At this stage, we focus on defining the structure of a database and its constraint, not on application code or physical storage. The goal is to clearly represent real-world data requirements before moving to implementation. Entity relationship modeling is a high-level conceptual data model used to design database applications. It allows designers and the users to communicate using shared visual representation called ER diagram. ER diagram helps capture entities, their attributes, and the relationship among them in a clear and structured way. Let us start with the core ER concept. An entity is a real-world object or a concept with independent existence, such as an employee, department, or project. Each entity is described using attributes, which represent its property. For example, an employee entity may have attributes such as name, salary, address, or birth date. Attributes can be classified in several ways. Simple attributes are atomic and cannot be divided further, while composite attributes such as address can be broken into components like city and street. Attributes may be single-valued or multi-valued, stored or derived, and may sometimes take null values when data is unknown or not applicable. An entity type defines a collection of similar entities, while entity set represents all instances of that entity type at a specific time. In entity relationship diagram, entity types are shown using rectangle and the attributes are shown as ovals. Key attributes which uniquely identify entities are underlined. For example, SSS may be a key attribute for person. Each entity attribute is associated with value set, also called domain, which define the allowable values. Domain enforces data validity and integrity by restricting the values an attribute can take. Next, we consider relationship. Relationship represent an association among entities. For example, workers represent the relationship between employee and the department. Relationships are shown as diamond in entity relation diagram. And in relationship have important properties. The degree of a relationship refers to the number of participating entity types. Most relationships are binary, but ternary and the higher degree relationship also exist. Entities play a specific role in relationships, especially in recursive relations such as supervision, where employees participate in both as a supervisor and the supervisee. And the relationships are further constrained using structural constraints. Cardinality ratios specify the maximum number of relationship instances, such as one-to-one, one-to-many, many-to-many, and the participating constraints specify whether participation is total or partial. Total participation means every entity must participate in relationship. Relationship may also have their own attribute. For example, hour in works on or start date in manage. These attributes describe the essential association itself, not the individual entities. Another important concept is the weak entity type. Weak entities do not have their own key and they depend on the owner entity for identification. They always participate totally in an identifying relationship. For example, dependent is a weak entity that depends on employee. Weak entities use partial key which uniquely identifies them with the context of their owner. Entity relationship diagram use standardized notation. Rectangle represent entity, oval represent attribute, diamond represent relationship, double line indicate total participation, and the double rectangle indicates weak entities. Entity relationship modeling is a part of broader database design. It begins with requirement collection and analysis, followed by conceptual design using ER model. The conceptual schema is then mapped to logical design such as relational database model, and finally implementation through physical design and application development. This chapter will focus on basic ER model as a foundation for clear and accurate and consistent conceptual database design.